Swayam Prabha. Digital India. Educated India.
Now come to the cruising range. Cruising range is when we want the most fuel economy. We are talking of best economy zone. So you have certain throttle opening, say from 25% to 75% throttle opening. So under normal cruising condition, you would like to have lean mixture. So normal power or cruising operation require lower fuel consumption than the maximum economy. This arrangement uses used as auxiliary port carburetor. So sometimes what you do is you make a bypass for the air. Okay. So this is auxiliary port carburetor, and there is a butterfly valve which gets operational only when you are beyond a certain throttle opening. So when you open this will open this at this level, this will start opening. So once this starts opening, that means the air will now bleed. It will not pass through this, so it will not cause too much of depression here. So only whatever air is passing through here, it will form a mixture of a certain strength. Then this bled air will mix and it will reduce the air fuel mixture strength. So overall what passes through this throttle will be relatively leaner mixture. So the arrangement used in the auxiliary port carburetor, where opening of a butterfly valve allows additional air to be admitted, and at the same time depression of the venturi throat gets reduced, thereby decreasing the fuel flow rate. Okay. So fuel flow rate actually decreases because you have bypassed the air. Now the third part is coming to the power range. Power range was the last range where you are pulling the maximum throttle. So obviously here you require very rich mixture. Why? Because you want to provide best power output. You also want to provide overheating. Why you want to enrich the mixture at power? Because if you are not enriching the mixture, the temperature will be so high that even your exhaust valve may start melting. So in order to keep the temperatures under control, you put more amount of fuel. So the maximum, you are still getting combustion, not complete combustion, temperatures are not very high. So this actually prevents the overheating of the exhaust valve by enriching the mixture, which reduces the flame temperature and the cylinder temperature. This is a very important part, why you enrich the mixture during power stage. Okay. This also inhibits the detonation. Particularly you must have seen that when we were discussing the detonation in the spark ignition engine, we were saying that chances of detonation are maximum in stoichiometric or slightly richer than stoichiometric mixture. If you make it too rich, just like we do in this, the chances of detonation actually reduce because the flame speed is going to reduce. Okay. So this actually helps us prevent the knocking as well, inhibiting detonation in aircraft engines by enriching the mixture beyond chemically correct, which reduces the flame temperature. Therefore, it reduces the possibility of detonation engine. So aircraft engine, when we are saying aircraft engines which are based on spark ignition engine, not really gasoline gas turbine engines, gasoline based aircraft engines. Okay. In automobile engines, detonation is produced in the form of audible knock, but in aircraft engines there is no audible knock because they are already so loud. If there is a metallic pinch, it will be suppressed by the noise itself, so you will never come to know about it. So automobile engines operate well below full power. Do you remember any time when you have pulled 100% throttle of your car or scooter or motorbike? At least I have never pulled in my life. Okay. So it is very difficult to extract 100 because you don't have that kind of conditions. But what about the aircraft? Do you have to really pull full throttle all the time, especially when you are taking off? At that time you need maximum power, so you pull max throttle. So aircraft engines are supposed to produce maximum power output when they take off. So automobile engines operate well below the full power, therefore enriching fuel air mixture will not be economical. But in aircraft installation, enriching the mixture is justified and necessary to increase permissible takeoff power. That is when you need maximum power during takeoff. So, how do you enrich? How do you enrich? So, we have seen that idling, how do we do the idling? We have seen that during cruising range, how do we lean the mixture? Let us now see if you have to enrich during the power mode, how do we do that? So, power enrichment system is used for enriching the mixture. This is a power enrichment system. It consists of a metering rod economizer that provides a larger orifice opening to the main jet as throttle is opened beyond a certain point. So, this is the metering jet, if it is pulled beyond a certain level, what this will do? This will lift this needle. So, when this lifts this needle, more fuel will flow through it, because now you have reduced the restriction, okay. And this opens only beyond throttle of 75% or more, okay. So, that is how it is done. You can also use accelerating pump system. This is for the power management. What about acceleration? Suppose you want more acceleration. When you are accelerating, you are at a certain load, you want to suddenly increase the load. And obviously, young guys, there is a lot of adrenal rush. They would like to buy a bike, you just press the accelerator and it goes zoom. So, challenge to the manufacturer, if they want to attract you guys to buy the bike which they are making, how do you make sure that you get significant amount of acceleration? By this system, normal system, it will be difficult, okay. So, for accelerating, you have something called accelerating pump systems. So, during sudden acceleration of the engine, an extra amount of fuel is momentarily required, only momentarily. When you are cruising, when you are accelerating, only at that time the extra fuel is required. How do you give that? So, when you give that extra fuel only for say 5 seconds or 10 seconds when the acceleration is expected, so you have to supply a rich transient, basically you have to momentarily supply this rich mixture. And how it is done? So, this is connected to basically, you see, what is the tendency? If you have to accelerate the engine, what do? You become impatient and you pull it too much, right? So, when you pull it too much, there is some kind of a linkage mechanism that is done, and there is this plunger is operated, and what this plunger does is it is filled with the fuel. So, when you have accelerated it suddenly, this pushes this valve, and from this valve extra fuel is injected into the airstream, and that is why momentarily you get extra fuel, rich mixture, and that gives you more feeling of power in that 5-second instant, right. So, this is obtained by accelerating pump system, which consists of a spring loaded plunger and necessary linkage mechanism. So, on a very simple aspect, such a accelerating pump system is used for accelerating, okay. Otherwise, when you are not accelerating, this will be just filled and it will have no role. Carburetor has to provide suitable mixture of in the transient conditions where speed, low temperature, pressure changes rapidly. The principal transition conditions of operation are starting, warming up, acceleration, deceleration. So, the difference between steady state and transient state are, so when you are operating at steady state and when you are in transient, that means you are changing the speed and load quickly. What is the difference? The difference is that the evaporation, there is hardly any time for evaporation. So, evaporation will not be complete, and then there will be fluctuation in quantity of liquid fuel in the intake. Suddenly, if you pump, you have seen accelerating pump system, you inject too much of fuel which has not evaporated. So, where it will go? It will stick to the walls. So, there will be too much of fuel in the intake manifold, it may increase or decrease depending on whether you are accelerating or deaccelerating, both are called transient states, okay. And then there will be distribution of the fuel cylinders. I told you that more fuel is in liquid state, you will have improper distribution of air fuel ratio between different cylinders of a multi-cylinder engine. So, this also happens, okay. So, starting and warm up. So, we will discuss these 4 operations, that means what happens when you start, what happens when you warm up the engine, what happens when you accelerate, and what happens when you deaccelerate the engine. So, let us look at starting and warm up. While starting from cold, the speed as well as the engine temperature, everything is low. Okay. Engine is at atmospheric temperature, lubricating oil is at atmospheric temperature. So, hence the fuel supplied by the carburetor does not vaporize, because everything is cold. Fuel is cold, carburetor is cold. And mostly when you inject, obviously there will be injection, because now the moment you start cranking, there will be vacuum, and because of the vacuum there will be suction, and because of the suction the fuel will be injected, but it will not vaporize. So, there will be a lot of fuel which will stay in the manifold in liquid form. Okay. And if there is some fuel that has vaporized by any chance, because that may even there is a possibility of recondensing. Okay. Recondensation will take place, and when they come in contact with the cold cylinder, recondensation may take place. And during the startup, therefore, in order to avoid this and still be able to start the engine, during the startup 5 to 10 times normal amount of fuel must be supplied for proper combustion or for the engine to start, 5 to 10 times. A lot of fuel is required, and obviously not all this fuel really burns. So, when you are starting the engine, so engine is nothing but carbon monoxide and hydrocarbon producing machines. So, when somebody is starting the engine from cold, always avoid inhaling the vapors. Okay, always. Never be behind a car which is being started or a scooter which is being started. As the engine warms up, the amount of evaporated fuel increases, and the mixture fuel ratio should be made leaner in order to avoid rich evaporated fuel air mixture. So, once the engine start, because of the conduction, convection, radiations, everything will warm up, and you have to avoid the rich evaporated fuel air ratios. You have to bring it as quickly as possible to the stoichiometric or lean side. Now, coming to the second, which is acceleration and deacceleration conditions. So, I told you that in the acceleration conditions, you have to have this kind of a well system. Fuel evaporated in the intake manifold moves faster than the liquid film formed on the induction valves. So, I think I mentioned to you that, for example, if there is a carburetor here and there is a film which is moving, so what will move fast? The droplets in the fuel vapor, or this film? Film will be the slowest to move. Okay. So, this creates a lot of problem. So, when the throttle is opened suddenly, the liquid film lag behind. So, you have put more extra fuel, throttle is pulled, you have put extra fuel, but half of this fuel has stick to the walls, and it is not moving as fast as the other half is moving. So, temporarily the engine cylinder receives a lean mixture, while the rich mixture is needed to produce instantaneous power for acceleration. So, that means this film is actually acting as a spoil sport. Okay. Now, during deacceleration you have reduced, but there is still lot of film. So, in the acceleration condition, the mixture becomes leaner than what is expected. In the deacceleration condition, it is just the reverse of it. It becomes richer than what is expected. Okay. So, to compensate for temporary leaning of the mixture and to provide rich air mixture for the acceleration period, additional fuel must be supplied by suitable mechanism. Okay. Now, what are the drawbacks of a simple carburetor? The drawbacks are that at low speeds, the mixture supplied by a simple carburetor is so lean that it will not ignite properly. The working of a simple carburetor is affected by the change in the atmospheric pressure. If the atmospheric pressure changes, it does not have anything for compensation. If you take it to Shimla or say Ladakh, where the atmospheric pressure may be 0.8 or 0.9 bar, you will have problem. It works on the carburetor depression. The moment the carburetor depression changes, because now the atmospheric pressure is reduced, its functioning will be affected. You have to retune it. If the fuel setting is done in the winter, it will give you too rich mixture in the summer, because in winter time you try to put more amount of fuel. So, it will give lot of emissions and lot of wastage fuel. in the summertime. So, you have to actually recalibrate, retune your engine every summer and winter. It is a good idea. It gives proper mixture of only one engine speed and load, therefore, it is suitable only for engine running at constant speed. Say for example, genset engines, they always operate at 1500 or 3000 RPM. For them, the simple carburetor will just work perfectly. It will be the cheapest device and it works it. But if it comes to automobile engines, such as motorbikes or such as scooters, a simple carburetor will not work. It has to have lot of other devices which we have just explained to you. So, quantity of fuel issuing out will change and not match with the velocity of air flowing through the venturi. Therefore, proper fuel air mixture formation does not take place with increasing or decreasing speed. And that is why simple carburetor is not suitable for automotive engine. It is more suitable for basically a genset engine. Okay. Now, let us look at compensating device. So, you need to basically compensate for different changing conditions. So, the tendency of a simple carburetor is to progressively enrich the mixture as the throttle is opened. So, more throttle you will pull, more and more fuel quantity will be put in. So, its tendency is that if it is a simple carburetor, richer mixture will be provided when the throttle is open maximum, most rich mixture. The main metering system alone will not be sufficient to take care of the needs of the engine. So, therefore, certain compensation devices are usually added to the carburetor along with the main metering system, so as to supply a mixture with desired air fuel ratio. A number of compensation devices are used. So, some of the important devices which are used are air bleed jet, compensating jet, emulsion tube, back pressure control mechanism, auxiliary air valve and auxiliary air port. So, these are some of the devices which are actually used for compensating the fuel that you are providing, provide extra fuel whenever required. I will discuss some of them today. Air bleed device, what is this air bleed device? So, you see here this is the throttle and this is the throat and this is your main nozzle. Okay. This is the main air bleed, this is the main air bleed and this is your main nozzle connected to the tank, float tank, and this is your float and this is the needle valve. Okay. So, this is the main air bleed. So, it contains air bleed into the main nozzle. So, basically an orifice that restricts the flow of air through this bleed. So, very low amount of air can actually flow in through here. So, what happens is that under normal conditions the fuel will be up to here and in this air bleed also the fuel will be filled up to here. So, under normal condition everything is filled with gasoline. So, when the engine is not operating, the main jet and the air bleed jet is filled with the fuel, everything is filled with the fuel. When the engine start, initially the fuel starts coming out from the main jet. So, when the engine is going to start, so the fuel will come from the main jet. Okay. As the engine picks up, only air starts coming through the air bleed. So, only the air will start coming in. So, what will happen is when the pickup takes place, you are opening the throttle, more and more vacuum will be created, more fuel will start coming from here. This fuel will also go into this and then additional air will start coming in and that additional air will make the mixture lean, right, that is what you want. So, as the engine picks up, only air starts coming through the air bleed and mixes with the fuel, making air fuel emulsion and making this air fuel mixture relatively leaner. Okay. So, this is one device, air bleed jet. The second device is called compensating jet. How it works? Again here you see this is compensating well. The tank is actually divided into two parts. One is this main tank, float chamber, and there is a small compensating well and there is an orifice. So, very small orifice. So that this tank fills very slowly. And this is your main jet, fuel metering jet, and from here this is the main jet. Okay. So, this main jet and this compensating jet both are located in the throat area, okay, and this is the throttle valve. Air is coming from here, air fuel mixture is going in that direction. So, in this method, in addition to the main jet, a compensating jet, which is this one, is introduced. The compensating jet is connected to the compensating valve. So, this main jet is connected to the main valve and this compensating jet is connected to compensating valve, okay, and it is also vented to the atmosphere. This is vented to the atmosphere. The compensating valve is supplied with fuel from the main float chamber through a restricting orifice. So, this is restricting orifice. Restricting orifice means that it will supply the fuel at a relatively very slow rate, okay. With the increase in airflow rate, there is decrease in the fuel level in the compensating valve. So, what happens when you are starting to use the accelerator, fuel will start coming from the main jet, fuel will also start coming from the compensating jet. So, after some time, this compensating jet will run out of fuel, this compensating valve, all the fuel will be gone, and this is supplying at a very, very low rate. So, now the fuel supply, when you are picking up or when you have reached a cruising speed, fuel supply will be only from the main jet, which is supplying less than desired. So, the overall air fuel mixture will therefore be relatively leaner. Is that clear? So, with the increase in airflow rate, there is a decrease in the fuel level in the compensating valve, and with the result that fuel supply through the compensating jet decreases. The compensating jet thus progressively make the mixture leaner as the main jet progressively makes the mixture richer. So, main jet is going to make it rich. Why it will make it rich? Because we have seen in the carburetor that when you pull more throttle, more and more amount of fuel is picked up, but this will reduce. So, overall it may be making it leaner or it may be maintaining the air fuel mixture ratio at the desired level, okay. Let me discuss one more device, which is emulsion tube. So, this is the emulsion tube. Again, here this is the throat and this is well. This is well and this is a submerged jet here. So, that means jet is coming up to this point, okay, and this is the throttle valve. And here you see this is another casing outside and there are vents here, okay. So, the air comes in, passes through these vents and takes away the fuel. The mixture correction is attempted by air bleeding in modern carburetor. A submerged jet is located in the bottom of the valve. So, this is the submerged jet. The sides of the valve have holes which communicate with the atmosphere, okay. In the beginning, the level of the fuel in the float chamber and the valve is same. So, in the beginning when you are starting, because of the holes there will be same level, and when the air comes in, what happens? The fuel will start evaporating. So, this well will get dried up, okay. So, when the throttle is opened, the pressure in the venturi throat decreases and the fuel is drawn into the airstream. This results in progressively uncovering of the hole. So, as it is drying up, as the fuel is drying up, it will lead to uncovering of these holes and leading to increasing air fuel ratios. So, the air is drawn through these holes in the well and the fuel is emulsified. The pressure differential across the column of the fuel is not high as high as that of carburetor, okay. There are three main types of carburetor. I will just take 2-3 minutes to finish this three types. So, there are three types. One is the updraft type. Updraft type means the fuel is moving upward against the gravity. So, that means the pressure here reduces and now the droplets will be carried by the friction of the air on the droplet surfaces. So, the air enters the bottom and leaves at the top, hence the direction of the flow is upward against the gravity. The disadvantage of this is that it must lift the sprayed fuel droplet by air friction. So, the air has to move. So, this is the drawback. Second is downdraft. Downdraft is this, the fuel comes out, but the air direction is this type. So, here the droplets will move not by friction, not only by friction, but also by gravity, okay. So, it is used to overcome the drawbacks of the updraft carburetor. It is placed in the level higher than the inlet manifold and air, and mixture generally follows a downdraft course, and the fuel does not have to lift by air friction, but move in the cylinder by gravity even when the air velocity is low. So, in the first case, in this case, the air velocity has to be a certain minimum level in order for the droplets to move into the combustion chamber, otherwise they will not be able to lift. But here there is no such issue, they will come down because of the gravity. But then the thing is that this has to be located at a level higher than the engine cylinder. This is the negative aspect of this. Cross draft. So, this is cross draft. So, air is coming in from this direction, fuel jet oozes like this, and then it goes in this direction. It consists of a horizontal mixing tube with a float chamber on one side of it. It reduces the resistance to flow by eliminating the right angle turn at the inlet passage. So, if you look at the types of carburetors, there are two main types of carburetors. One is called constant choke carburetor, the other one is called constant vacuum carburetor. So, in constant choke carburetor, the air and fuel passage areas are always maintained constant. So, basically the areas are constant, but the pressure difference which causes the air and fuel to vary as per demand. So, the flow of fuel and air is varied by changing the pressure difference, but the areas are constant. So, therefore, it is called constant choke. Okay. Constant vacuum carburetor, in this air and fuel areas are varied as per demand in the engine, while the vacuum is maintained to be constant. Okay. So, the examples of constant choke is Solex and Zenith carburetor. This is an assignment, you should note it down. Solex and Zenith carburetor and SU and Carter carburetor. Please read about them on your own, they are a part of the syllabus, and please read about the designs, what are the salient features and how do they work. Okay. So, we have multiple venturi carburetor. We have seen that in simple carburetor there is only one venturi. Okay. So, when you need to vary the pressure or create the vacuum here, boost venturi is located concentrically with the main venturi. So, there is a main venturi, and concentric to this there is another venturi. So, this is double venturi system. In a triple venturi system, this is the main venturi, there is another venturi, and inside this there is another venturi. Okay. And please see, this fuel line that is coming in is actually coming to the throat of the smallest venturi. Okay. So, what it does? So, the main venturi is located concentrically with the main venturi, and boost venturi is located concentrically with the main venturi, and the discharge edge of the boost venturi is located in the throat of the main venturi. Okay. So, discharge edge is this. So, boost venturi discharge edge is located in the throat of the main venturi. So, please see, this edge of this venturi has to be in the middle of the main venturi. Similarly, you can see here this venturi, it is located here in the middle, this venturi, the edge is located in the middle of the middle venturi. Okay. So, so what happens is, when you have a smaller venturi, so when the air is coming in, only a part of the air will pass through it, the remaining air will bypass. Okay. So, only a fraction of the total air flows through it. Pressure at the venturi, boost venturi exit, which is this one, equals to the pressure in the main venturi throat. So, whatever is the pressure here, it will be the same as what is there in the throat. Okay. So, better control over the fuel flow is obtained because the high depression is created in the region of the fuel nozzle. So, here is the fuel nozzle. So, here you will have much higher depression compared to this place. Okay. So, delta H actually will be much higher, the vacuum difference will be much higher here, here it will be even more. Okay. So, once you have something which is higher, you gain more control on it. So, better control of the fuel flow rate as high depression is created in the region of the fuel flow nozzle, and this is excellent at low speed full throttle operation. So, if you are operating the engine at low speed and you want to pull the throttle, that means the engine is now running at low speed and you want it to generate high torque. So, at that time you would like to have more fuel supplied for the same quantity of air, for small quantity of air. So, that is possible by this system, because here there is more vacuum that is created. So, more fuel will come in for the same amount of air, and therefore, you will be able to enrich the mixture. And if you look at the performance, high performance bikes for example, in high performance bikes, why do you feel that this bike is more powerful compared to the other bike? What is it, that parameter that gives you that kick, especially for the youngsters who are driving the bike? It is actually the low power torque. So, the bike which is giving you high low power torque, okay, that gives the kick to the people. You want to be the first one to cross on the red light, right? That is a normal tendency among the youngsters, and that is why, that is where you can show to the world that okay, your bike is the most powerful, it accelerates fast. So, it is not so, it does not really so much matter when the speeds are high, but at low speeds you would really like to show that there is high torque, and high torque can only be generated when you have rich air fuel mixture. Rich air fuel mixture requires that for the same quantity of air you put in more amount of fuel, and that is possible by this intervention. Clear? So, that is the context. So, more, and then since there is more control, you are having more efficient mixing of the fuel with the air, and then here in the center you have vaporization, and here the air is coming, that is just plain air, there is no fuel in there. Okay. So, then an annular blanket of the air is formed, and this will this way very little amount of fuel will stick to the walls. So, most of the fuel that you put in this kind of a carburetor will be contained inside the flow itself. Very little will go and stick to the walls, because there is a air blanket. Okay. Of course, eventually everything mixes, but this helps you reduce the thickness of the layer that is present on the cylinder walls. So, there are many advantages. So, first is that it reduces the condensation on the fuel on the cylinder walls, and that is a big problem, because when you require more torque, less fuel is available. When you require less torque, more fuel goes into the cylinder because of the wall film. And there is a high speed system, okay, because the air that is going through cascade of boost venturis is actually much fast, and it creates more depression, carburetor depression, that allows more fuel to be pumped in. So, you have much better control. Okay. So, I think this more or less in the spirit I have shown you that the problem of distribution also is there in case of a carburetor. For example, if there is a carburetor where you are putting air and fuel, and there it is a multi-cylinder engine. So, what will happen is that there will be air fuel vapor that will be created, there will be some droplets that will be traveling, and there will be a lot of film on the manifold walls. So, the cylinders, each of the cylinder, for example, it could be 4-cylinder engine or 6-cylinder engine and only one carburetor. So, what will happen is eventually each cylinder theoretically must get same air fuel ratio, but when you look at it practically, not every cylinder gets the same air fuel ratio. And so, there is a problem in the fuel distribution between the cylinders. So, problem in the distribution comes in multi-cylinder engine, as the carburetor must supply air fuel mixture to reach several cylinders. It is not possible to obtain complete atomization and vaporization of the fuel by carburetor. So, whatever you do, there will be some fuel which will be forming either the film or it will be hanging around as droplet. So, mixture passing through the intake manifold generally contains some fuel in droplet form. Also, there exists a thin film of the liquid film which adheres the inner walls of the intake manifold, and it causes uneven distribution. Why uneven distribution? Because droplets have inertia. So, they will not like to go to the turning flows, they would like to follow the straight flow, and they here when they come to the extreme cylinders, they have no choice but to go to the last cylinder. So, this cylinder, extreme cylinders will get richer air fuel mixtures, and the central cylinders will get linear air fuel mixture. So, partial solution could be that the air that you could preheat a little bit. So, when you preheat, the most of the fuel will evaporate, and homogeneous mixture formation will take place. But then preheating the air is full of other problems, and the first problem is that when you preheat it, the density of the air goes down, and once the density goes down, the volumetric efficiency of the engine will go down. So, there will be less mass of the air going into the system. As a result, the torque output of the engine will eventually reduce. So, another solution is to enrich the overall air fuel mixture, so that the leanest cylinder, that is the central cylinder, receives the desired air fuel ratio. But then the problem here is that once this is getting the desired one, the extreme cylinders will get more than desired, and therefore, that fuel, extra fuel, will be going to the extreme cylinders, and which will burn inefficiently, which will create lot of pollution, because if you are putting fuel above stoichiometric, richer mixture than stoichiometric, obviously it will give rise to formation of hydrocarbons and carbon monoxide, which is a pollutant. Okay. So, when an engine starts, extra fuel floods the inlet manifold. So, the engine starts on a very rich mixture. We have seen that when the engine starts, we really want to put in too much of fuel, and then what happens is that many a times this fuel, because everything is cold when you are starting the engine in the morning. So, fuel will not evaporate, and even if it evaporates, it recondenses and it forms a film on the manifold walls. So, if the film is there, is something undesirable and you do not want that to happen. So, often you provide small ribs to control the flow of liquid film. You do not want the liquid to be flowing through the walls, it should separate and it should get resuspended into the air stream. So, what you do is you provide either some ridges, so the fuel can really jump and again re-entrain itself into the flowing air, or you provide sharp corners. So, for example, the fuel is coming like this, and these are the droplets, and this is the film. This is a little exaggerated picture just to show the concept. In the actual practice, the fuel film is never so thick, okay, but this is just exaggerated picture. So, you see there is a film which is flowing and there is air flow. So, there is a friction with the air. So, it will move in a certain direction towards the cylinder, and then what you do, you do not want this to really flow, you want to break this, and you want this fuel to get suspended into the air. So, you provide some sharp corners, so that on this sharp corner there is a build up of the pool and build up of the fuel pool, and then it separates itself and then it gets resuspended. So, this is what happens. So, in a simple branch manifold with a single point injection system, the intersections have sharp corners to break up the liquid film flowing into the manifold walls. So, sometimes the sharp corners can break, sometimes you provide extra ribs, the small ribs in the flow path, because you would know by the design itself what will be the flow path of the fuel, and in those areas you try to provide ribs, so that you can resuspend it. Okay. With the use of multiple carburetor installations, the aerodynamic performance of the inlet manifold improves. So, sometimes what you do is, instead of putting one carburetor for all cylinders, you put one carburetor for one cylinder, and then that problem is solved, because then every cylinder will be getting same air fuel ratio, but then the cost goes up. So, sometimes this is done. Now, you see this is very important how the fuel distribution is, and if you look at this cover, this shows the variation in the air fuel ratio requirement with load at constant speed. And what you see here is equivalence ratio. So, this is stoichiometric, this side is lean and this side is rich, okay, and this is the full throttle. So, throttle from 0% to 100%, throttle is varying in this direction. So, first you see the lean limit. In an engine, there is at every throttle there will be a certain equivalence ratio which can really burn. Okay. So, if you look at this is the lean limit. So, when you are 100% throttle, you will be able to burn the leanest mixture. When you are at low load or no load condition, or throttle is either partly closed or very little open, at that time you require richer mixture. That is why this line is inclined like this. Okay. If you look at the rich side, on the rich side also this is the line. So, on the rich side, when you enrich, when you pull the maximum throttle you remember where was the maximum throttle? In the high power range. So, high power range we generally enrich the mixture, this is the high power range, right. This is the starting range and this is the cruising range, that is the throttle, if you try to draw the parallel between throttle position and driving range. So, you see in the rich limit you can go really rich for full throttle, but when you go to low loads there is a lower richness that is required. So, this is the rich limit. And then you remember we made two curves, one was the power curve, when you get the maximum power output or maximum torque output from the engine, and there was the economy curve where you would like to really operate the engine under most economic conditions. So, then you look at this is the maximum economy curve. Okay. So, this is where you get the minimum brake specific fuel consumption, BSFC, minimum brake specific fuel consumption, and this was the maximum power curve. Okay. So, fuel distribution, if distribution is not proper, all this fuel economy, power output, everything will be affected. Okay. And actually if fuel distribution is not appropriate, then you may actually go out of this and you may also go out of this. Okay. So, therefore, distribution it is extremely important that you keep the fuel distribution, design your carburetor in such a manner that you are within this zone. In fact, I would like to say that you are within this zone for most operating conditions. Okay. So, when the throttle is opened, extra fuel is needed for several reasons. First is that the airflow into the engine increases when you are pulling the throttle, you are opening the throttle, and this actually increases more rapidly than the fuel flow rate, because first the air has to increase, then the vacuum will be created and then the fuel will increase. So, obviously the engine airflow increases much more rapidly than the fuel flow rate, since some fuel is in the form of droplets and some is present in the form of films. So, that also by the time it reaches, it reaches really slowly compared to the air. So, for maximum power a rich air fuel mixture is needed, and when the throttle is opened, vaporized fuel will tend to condense. When you are opening the throttle, more fuel comes in and there is a possibility that it may recondense. Okay. When the throttle opens, the pressure in the manifold increases, also the partial pressure of the fuel vapor also increases. So, if the partial pressure of the fuel rises above the saturation pressure of the air, when you have more moisture in the air, what happens? Condensation happens. Similarly, if the fuel is more than what the air can hold, it is above the saturation limit, obviously the condensation will happen, and where that fuel will condense? On the cylinder walls, okay, on the manifold walls, not the cylinder wall, manifold walls, and then the fuel will condense, and then if the fuel condenses, obviously the fuel is out of the equation. So, you need to put in more amount of fuel. So, extra enrichment is required. Okay. When the throttle is suddenly closed, so at that time the manifold pressure suddenly reduces, it causes the fuel films to evaporate, and then all that fuel gets suspended, and this provides really an over rich mixture when you do not need it, because you are already closing the throttle, you do not need it. Okay. So, this leads to the problem of emissions of unburnt hydrocarbon. So, this is also a big problem. Okay. This problem can be overcome by spring loaded overrun valve of the throttle valve plate that bypasses the air into the manifold. So, sometimes heated manifolds are used to reduce the liquid film formation and also the droplets of the fuel that are suspended, but then it is a problem. It is a problem because heated manifold is going to heat the air as well, and then that reduces the volumetric efficiency. So, the manifold can be heated electrically, manifold can be heated by coolant heat is free, you are not spending any energy, or by conduction from the exhaust manifold, that is also free. If you put electrical heater, obviously you are drawing you are paying for the energy, but if you are using coolant or exhaust gas, it is a free energy, you are already anyway wasting it. So, the disadvantage of heated inlet manifold is this leads to reduction in volumetric efficiency, and therefore, consequently torque output and power output from the engine. Supplementary heaters are often used, such as the ones with PTC, which is positive temperature coefficient materials. Okay. So, this gives automatic temperature control. So, basically positive temperature coefficient means when you heat them up, their resistance actually reduces. So, progressively you heat, at the cold conditions they have higher resistance, at the when they get heated up the resistance actually changes and reduces actually. Okay. So, the heater employ extended surfaces which are usually splines. Splines you apply, splines you know what are these splines? So, extended surfaces like fins, internal splines and external splines. External splines are called fins, and then if they are internal it is called spline, and the arc located in the manifold under the carburetor of a single point fuel injector. Okay, so basically you make some kind of a structure on the surface in order to increase its surface area, and when we increase the surface area, what happens to the heat transfer? It increases, and then when it increases you will be able to heat your air from the waste heat of coolant or exhaust gas. So, it is quite usual for carburetor to give plus minus 5% variation in the mixture strength between the cylinders even for the steady state operation. So, whatever you do, if you have a multi-cylinder engine, you will have 5% variation in air fuel ratio for sure, and it is acceptable even in steady state condition. So, let us see, the thing that you have to understand is that air fuel ratio from a carburetor is extremely important, and the main reason for designing a carburetor is to get the air fuel ratio of desired strength.